Okay, so I'm going to try and go over some of the calculations that we did in the tectonics lab. And so what I'll just start out with saying is most of the issues that students have with the calculations isn't really the math part. It is converting between the different units. So there's two conversions that we have to keep in mind here. One is converting within the metric system. So that's a base 10 system, but you still need the conversion factors, like what's the relationship between different units. And then, of course, it's converting between the standard system that we use here in the US, which is, feet, inches, and miles, into the metric system because, of course, everyone else uses it but us. So, it's practical that if you live here in the US, you will be using the standard system and you'll have to change that. So, if we look at one of the questions in the lab, I think this was one of the first ones here. It wants to know a rate. And so remember that a rate is just distance divided by time, which in and of itself isn't too difficult. But what you're given here is you're given the rate, or you're given the time, which is 2 million. So you got to remember, you have to use all the fun zeros. That's going to go down there. And then you're given a distance, which is 224 kilometers. Now, really, you could just plug this in your calculator and you would get a rate, and that would be technically the correct answer, except that we wanted the rate to be in a specific units. So as you look at the question, it says it wants it in centimeters per year. And if we did this division here, we would get it in kilometers per year. And so the problem here is that you need to convert. And so the things you need to know is the conversion factors. There is a, 100 centimeters is equivalent to 1 meter, and 1,000 meters is equivalent to 1 kilometer. You need this information to convert our kilometers. Now we can cheat a little. In theory, we would have to do 2 conversions to change kilometers all the way to centimeters. There is a conversion that just says 100,000 centimeters. That is equivalent to 1 kilometer. So there's a relationship between kilometers, which I have in my top part of my fraction, and centimeters, which is I want the answer to. So for a minute here, I'm going to take this kilometers away from my equation and just convert it. So here I have kilometers. I want to change it to centimeters. So typically what we do is we just say we're going to multiply by a conversion factor. And so what I want to do is put the unit that I want to get rid of down to the bottom of the fraction. So I'm going to put my kilometers down here. And what do I want to get to? I put in the top. I put that up here. Okay, and so then I use this relationship to plug the values in. There's 100, kidding, there's 100,000 centimeters in every 1 kilometer. And so now I can say that the kilometers will cancel and my answer will be in centimeters. So what I want to do to convert this is multiply 224 by 100,000. So yes, it is a big number, but remember we're eventually going to divide by 2 million. And so what we get is 224. We're going to multiply that by 100,000. We get lots of zeros. So we get 22,400,000 centimeters. So that can replace that. They're the same thing, they're just different units, right? It's like saying you're 6 feet tall or 72 inches tall. You're the same height, just different units. So now we're going to take the 22,400,000 and divide that by 2 million. And when we do that, let's see, I'll do that in my little calculator just to make sure I do it right too. We get 11.2, and that's in centimeters. And of course, this is years and this is centimeters, so it's centimeters per year. And this is your answer. So most of the problem comes from either not converting at all and just staying with the kilometers, or that you when you did some division here, you didn't add a zero. There are a lot of zeros here. So even just a calculator error, you're plugging things in your calculator and you're forgetting a zero or something like that. So that certainly can happen. And so the other things that we do for the problems here, see if I can get rid of most of this, we'll keep the conversions up there, is now we're just going to do some more math, and it's the same thing. The key here is the units have to be correct in order to get the right answer. So if I have meters and centimeters, I can't divide those two because they're not the same. I want meters to meters or centimeters to centimeters. So let's see, what's the best one that kind of illustrates that? I'm trying to find one of the other problems here. We did that one. Okay, maybe we will do this one. So in one of the other questions, it just said that we had an island chain that was 372 kilometers from a certain location, and I want to know how long. So I'm looking for a time here. So how long would it take? And we're going to use our previous rate. So if we looked at the equations, it said that time, oops, I don't want to erase, said that time is going to be distance divided by my rate. Well, remember, I just calculated my rate. So this is, I'm going over the lab itself. So we calculate a rate in the first problem, and then it wanted you to use that rate in the second problem. So we know that this is 11.2, but it is centimeters per year, remember. And you're given, for the distance, you are given 672, but what is that in? Kilometers. Okay, you can't do this division because we want the units to be the same. Okay, and so what we need to do is convert kilometers to centimeters, just like we did before. So how do we do that? We take our 672 kilometers and we're going to multiply by a conversion factor. I want to get rid of kilometers and I want to get to centimeters. I'm going to use this conversion factor here, so I'm putting my 100,000 in there, put my 1 there, and just do the math, right? So multiply 672 times 100,000. Of course, these will go away. And so when we do the 672 by 100,000, we get our dreaded 67,200,000, and that's in centimeters now. So once again, I can replace that. And then what I see is my centimeters will cancel, it'll give me a year. And so I'm just going to take that 67,200,000 and divide it by 11.2, and I get 6 million, and that's in years, right? So I basically took my 67,200,000 centimeters and I divide it by my 11.2 centimeters per year. Those cancel and I end up with years, and this is the answer to that second problem. So like I said, the biggest hurdle is usually that you forgot to convert, or in your converting you entered too many zeros, maybe used the wrong conversion factor. So there's certainly places where you can make mistakes here. There's some big numbers that you're using, and so that can come into play too. I think the last one I'll do just to help you out here is there's this one about, let's see, is this the one? I don't think I was mean, and that mean is relative, right? So then there's the third one. There's a distance problem. That's just rate times time. And so I think in the very last question it said 260 million years ago the North American plate was joined, right, in a big supercontinent, and then it split apart in the middle and moved away from each other, and that is the Atlantic Ocean we see today, and it's still moving away. And so what we want to know is, if it moved away at a constant rate for 260 million years, how far away would they be? So we want a distance here. So this is our last one. So our distance is just our rate times time. So as we look at our formula, so distance equals our rate times time. So same thing. Don't forget that when you're using time here, we're going to go 260 million, right? So we got to put in all those zeros. and I need a rate. So I'm given a rate. I'm given a rate of 1.5 centimeters a year. Now, technically, you can do this two ways. If I have 1.5 centimeters per year, okay, what I can do is I can multiply, and I'll have an answer that's going to be in, it's going to be in a distance, but it'll be in centimeters, right? So that's not very useful to me because that's not a good measure of distance when we're talking big distances. So I want it in kilometers. So I can either convert this before I multiply, I can convert it to kilometers and do that, or I can do it after. So let's do it after just to see if we can make that work. So all we're going to do is 1.5 is going to get multiplied by 260 million. And I get 390 million. Okay, and this is in centimeters. Well, that's nice, but I don't know how big that is, so I want it in kilometers. So remember, there is a relationship here. So what do we say we do? We convert. We're going to multiply by a fraction here. We can always imagine that any whole number is written as a fraction like that with a 1 at the bottom. So what I want is get rid of centimeters, because they'll cross out like this, and put kilometers here. So by placing them in the right spots, now I see that I'm going to actually divide. I'm going to take 390 million, multiply it by 1. I'm going to write that over here, sorry. 390 million. And I'm going to divide that by 100,000. And so basically you get a lot of zeros canceling. But if you do that, then you should get 3,900. And this is in kilometers, because remember, we're getting rid of our kilometers, or our centimeters here, and we're ending up with kilometers. And so something like that, right? And so this is our answer for the distance. So I'm not sure if that is helpful. I hope it is. But the key here, remember, is converting, and converting correctly, using the correct conversions. Now, like I said, there's a lot of zeros here, so sometimes you get crazy with the zeros. You forget a zero, you miss a zero, but you have to have them in the same units. The key is to look at what you're starting with, what you want the answer to be in, and then you can use that to figure out when you have the, what you have to convert to, and then pick the right conversion, and then just do the little conversion before you do the math, before you plug it into the formula. You want to make sure they're all in the same units, and then you can make it work. So hopefully that helps. If not, you can always drop me a line and let me know.